Hey guys, here's a video on some of the laws of logarithms that we learned. So there's the power law. We proved it in class and it works just like this. So if you have log base b of x to the power of n, you can actually move that n to the front to make it n times log base b of x. And that could be helpful too when you're evaluating some logarithms. So, for example, maybe you have a question like, I don't know, log base 2 of 16 to the power of 3. You don't really want to do 16 to the power of 3 because that's going to be some humongous number. And we can actually solve log base 2 of 16 pretty easily. So we're just going to move the 3 out front to make it 3 times log 2 of 16. And then we can just solve log base 2 of 16 because we know 2 to the power of 4 is going to equal 16. So I'm just going to replace this with the number 4 because that's what that equals. Log base 2 of 16 is equal to 4. And then I can just do 3 times 4, and so I know it equals 12. So this power law just allows us to move an exponent to the front of our logarithm. So that's what the power law is. We have something called the product law. And the product law is when you have log base b of m times n, you can actually split this up into log base b of m plus log base b of n. So you can actually split this product into an addition problem and vice versa. You can go both ways. So maybe I have something that I can't easily solve as a separate thing, let's say. Or wait, let's break it up. Like, I don't know what a question would be, but say I had log of like 3x. If I wanted to, I could write that as log 3 plus log x. So I can actually split up this product into a 3 and an x. Or maybe I want to go the other way. Like maybe splitting it up will help me evaluate a log. So maybe I want to do something like log base 6 of 18 plus log base 6 of 2. Maybe those are kind of tricky to evaluate them like that. So I'm going to use my product law. I know I can write them as a single logarithm. I can say log base 6 of 18 times 2. So 18 times 2 is 36. And now I can solve this a little easier because I know that 6 to the power of 2 is 36. So the answer to this is just 2 because I know 6 to the power of 2 is 36. So my final answer is 2. But getting there from this step would have been tricky because I don't know what those are. So sometimes that product law can help us. Then there's also a quotient law, which is similar. And the quotient law says if you have log of something, like I'll just put a b, of m divided by n, I can split that up into log base b of m minus log base b of n. So same thing we just did. If I had like log of, I don't know, 4 over 3, I could split that into a log 4 minus log 3 if for some reason I needed to do that. And sometimes it could just help me evaluate stuff. So maybe I have a log base 3 of 54 minus log base 3 of 2. Those are kind of hard to evaluate on their own. So I'm going to switch it into log base 3 of 54 divided by 2. I'm going to use my quotient law to write these as a quotient. Then I'm going to actually divide them. So log base 3 of 54 divided by 2 is 27. And then I can just see, okay, 3 to the power of what equals 27? 3 to the power of 3. So that would be my answer. So that's how you can use the quotient law, product law, and the power law.